Welcome back to another Daishinfinity video. In this video, we're going to prove the so-called Bernoulli's inequality that states that for all x element r with x bigger or equal to -1 with n element the natural numbers, states that every 1 plus x to the nth power is bigger or equal to 1 plus nx. So I would like to prove this to you guys using induction. Let's start by using the induction principles, starting with the first number. Let's say since we have for all n in the natural numbers, let n not, so the starting point, be equal to 0. Then it will mean that if we plug in the 0, it will mean that 1 plus x to the 0th power is bigger than or equal to 1 plus 0 times x. Now 0 times any number is 0. So we have 1 on this side, and anything to the 0th power is equal to 1 unless x is -1. If x is -1, we have 0 to the 0, and 0 to the 0 approaches 1, so we have to approach 1 from the right side. That is the thing we have to actually be careful of. Okay. So 1 is equal to 1. Since 1 is equal to 1, 1 is also bigger or equal to 1. So it actually proves the first and not. Now let's suppose that for all n element n and for all x element r bigger than -1, that the inequality 1 plus x to the nth power is actually bigger or equal to 1 plus nx. Okay, now let's prove it for n plus 1, which is also in the natural numbers, since the natural numbers are governed by the piano axioms. So if we prove it for the n plus 1th iteration, we can prove it for all natural numbers, since every natural number comes after a natural number. So we have to prove it for 1 plus x. So we have to prove 1 plus x to the n plus 1th power is actually bigger or equal to 1 plus n plus 1 times x. If we can prove this, then we can prove that it's actually real. So let's start by the left-hand side with the parentheses 1 plus x to the n plus 1th power. We know that through some rules that a to the n times a to the m is equal to a to the n plus m. So we can actually write this down as 1 plus x to the nth power times 1 plus x. Okay. Now, since we have 1 plus x to the nth power, we know that we suppose that this is actually bigger or equal to 1 plus nx. So we can actually say that 1 plus x to the n plus 1th power is actually bigger or equal to 1 plus nx times 1 plus x. Now, how can we go forward? Now we can still say that 1 plus x to the n plus 1th power using the distributive rule that it is bigger or equal to 1 plus x plus nx plus nx squared, since we distribute the parentheses with one another. And now we can use a small trick to get back to what we actually wanted. So we actually want to prove the following. We want to prove that 1 plus x to the n plus 1 power is actually bigger or equal to 1 plus n plus 1 times x. Now, we have to kind of have this on the right-hand side of this one. And if we have it, then we actually have proven the induction. So how can we go forward? We still have 1 plus x to the n plus 1th power is bigger or equal to 1 plus x plus nx plus nx squared. Now what about x plus nx, we can actually put the x out of it to have two products overall. So we have bigger or equal to 1 plus x times 1 plus n plus nx squared. Why am I doing this? This is what actually I wanted to do. I wanted to have the n plus 1 because 1 plus n is n plus 1. And we have the x and the 1. So we are almost there. We just have to get rid of this. But we already know the properties of x squared. We know that for all x element r, that x squared is greater or equal to 0. Which means that for all n element natural numbers, since all natural numbers are positive or equal to 0, nx squared is also bigger or equal to 0. So if we have this positive term here, nx squared, and if we just eliminate the nx squared, it should obviously be bigger than 1 plus x times n plus 1. So we can actually say that 1 plus x to the n plus 1th power is bigger or equal to 1 plus x times n plus 1 plus nx squared, which is also bigger or equal to 1 plus x times n plus 1, since this term is positive. So now we have proven that 1 plus x to the n plus 1 power is actually bigger or equal to 1 plus x times n plus 1. This is actually what we wanted to prove. So I hope you enjoyed this video. Please like and subscribe, and if you have any questions, then leave them in the comments. And we'll see us in the next Daishinfinity video. See ya.